So here we are with our 3-2 notes, and we're actually on day 2, where we're going to talk about angle measures when you have two parallel lines and a transversal. So again, the biggest idea today is that now these lines are not just lines, they are parallel. So if we take a look at this diagram here, hopefully you can see that we have these parallel markings, okay, and so those mean that those two lines are parallel. Because those two lines are parallel, we end up having a lot of matching angle measures, and so we'll talk about those in a minute, but before we move on to that, I do want to kind of list all of our corresponding angles and all of the pieces. So again, in review from our previous assignment, hopefully you can immediately find corresponding alternate interior, alternate exterior, etc., all of these types of angles. So there are in fact 4 pairs of corresponding angles, so if you want to pause the video and actually take the time to write those down and see if yours match, now would be the time. Either way, I am going to write the corresponding angles, so angle 1 and angle 3 are both in this upper left part of this intersection, and so those are going to be a corresponding angle pair. We also have the upper right part there, and so angle 8 and angle 6, for instance, are a corresponding angle pair. I also have angle 2 and angle 4, which are a corresponding pair. And then, let's see, the last set would be 7 and 5. So in this diagram, those are every single set of corresponding angles. All right, then we have alternate interior angles. There are only 2 sets of those. So again, trying to find alternate of the transversal inside, in this case, the set of 2 parallel lines. And there are only 2 sets like that. So angle 7 with angle 3, the opposite side, and then angle 2 with angle 6 are going to be alternate interior angles. The next piece are your alternate exterior angles. So for instance, angle 8, but then if you transverse this line here, we're going to go to angle 4 for its pair. And then that leaves 1 with 5 for the other set. All right, then we have same side interior angles, so again inside of the set of parallel lines, and then of course on the same side, because it's the same side interior. So for those, we're looking at angle 2 and angle 3 as a set, and angle 7 and angle 6. And then we have a bunch of vertical angles. In fact, there are 4 sets of vertical angles, and oh my gosh, like what, 8 sets of linear angle pairs. So yikes. Okay. So vertical angle pairs, I've got angle 1 with angle 7. Okay, so across from each other at that X. Then we also have angle 8 and 2, which is also in that set. There's also angle 3 and 5. And then the last set, angles 3 and 5, 6 and 4. So again, vertical angles are the ones that are across from each other. All right, then we have linear angle pairs, and basically that means they are next to each other, or they're going to be adjacent. And so we just need to mention every single set of adjacent pairs. So for instance, 8 and 7, and 7 and 2, and 2 and 1, and 1 and 8, those would all be pairs that make up a line. So it's a lot of them, so I'm just going to start writing them. So let's see. In red I did 8 and 7. Whoops. And then I have 2 and 7. And then I drew a line between angle 1 and angle 2. And then angle 1 and angle 8. So lots of linear pairs make up a line. And then going down to the bottom piece, angle 6 and angle 5 are also a linear pair. Also angle 4 and angle 5 make up a line. Angle 3 and angle 4. And then the last set of 3 and 6. All right, so Again, those are all of the sets. And so from that assignment from the day one, you should be able to kind of identify, if not immediately, with practice, what each of these are. So now that we've reviewed a little bit about our angle pairs and introduced the fact that now these lines that are intersected by a transversal are parallel, again, due to parallel lines, it turns out that all of these pairs that we've just mentioned are either going to be equal or supplementary. So again, on the previous page, all of these, for instance, I understand corresponding angles are in fact equal. That would mean that if I knew measure of angle 1, it would equal angle 3. And if I knew angle 8, it would equal angle 6, okay, because they are corresponding angles or equal. So putting those under here, corresponding angles are in fact equal. Perfect. Looking back at our other angles, alternate interior angles, and maybe you can see that if you look at them, or maybe even get out that super duper measuring device that I actually gave you. You can actually measure these. I wouldn't necessarily always just measure things in our diagrams because they're never usually drawn to scale, but I am giving you permission on this one because they are drawn to scale, that the angle that you find at 7 will actually measure the angle you find at 3. So that means that our alternate interior angles, and it turns out also the alternate exterior angles, are congruent or equal. Same side interior angles, however, are supplementary, so that's an interesting change. Vertical angles are in fact equal, so those would go under this column. And then, of course, linear pairs make up a line, and so they would be supplementary because lines are supplementary. So that's the idea there. We've got our side of the column here that has equal measurements, and then we have the supplementary ones. So anytime that you see these pairs, you know that they're either going to add to 180 or are equal. So taking a look at our next diagram, if we calculate our angle measures, and we know that angle 1 is 30 degrees, we can actually find every single angle in this diagram given that angle 1 is 30 degrees. Now, if you actually got out your protractor, as I mentioned earlier, you probably measured angle 1 and it did not give you 30 degrees. That's perfectly fine. Again, most diagrams are not used as scale drawings. They're just used to kind of show a concept. Okay. So later on we will get to actual construction of these, and so that will be good to know the theorem as we construct them. So either way, 30 degrees is going to be angle 1. And so from a lot of different options, we can actually find out what the other measures are. So for instance, angle 1 is in a relationship with angle 8, right? They're both here on top, and as we mentioned in the previous one, 1 and 8 are a linear pair. So remember that 1 and 8 then would be a linear pair or supplementary. So I'm going to write given for this first one. It's not really a proof, but anyway. And then I'm going to skip down to angle 8. If this is 30 and I need 180 total, what am I going to add to 30 that would make the measure of angle 8? So again, 30 plus something I don't know is supposed to be 180. Take away a 30, and you're left with that thing you don't know as 150 degrees. So that means that angle 8 is 150 degrees. And how did I know that? Because they're a linear pair. Not because they're supplementary. That's the definition. It's that the reasoning was it's a linear pair, and now I know I can make them supplementary. All right, then let's see. Taking a look again at angle 1, angle 2 is a linear pair with it. So I'm going to go and jump up to angle 2 and say, okay, well that's going to have to be 150 as well, again because it's a linear pair. The next piece, angle 7. So hopefully you can see that angle 7 in relation to this 30 degrees, they form an X, and so angle 7 is a vertical angle to that. So a vertical angle, as we saw in the previous table, vertical angles are going to be equal, and so that means that it's going to be 30 degrees as well. Now that we've kind of gotten this top part, we're now going to go to this bottom part. So how do I skip from this top intersection to this bottom intersection? Corresponding angles. So angle 30 is in the top left, and so is angle 3. So angle 3 is going to be corresponding, and corresponding angles are equal, so that's going to be 30. From there, you can use the same things that we did before. Angle 3 and 6 are a linear pair, and so that's going to make the angle 6 180. Oh, sorry, 150. The next one is 4, so angle 4 is also 150, and again that's because of a linear pair. And then the last one is angle 5, and again at that intersection 5 is across from 3, and so by vertical angles we get that that's going to be 30 as well. So lots of ways that you could have gone through this, and again hopefully you didn't get out a protractor to measure this. The idea was that we could use our concepts of angle pairs in order to say if something is 30, for instance in this case, what would every other angle in this scenario have to be? So that's what you're going to do on your assignment, is kind of go through these ideas and find answers based on their relationship or their angle pair.